Here I show you the experimental setup. It is a Kacher resonator, a very useful toy which I use often. It is grounded here with the red wire only to the battery. It's not connected to a real earth ground. And I show you, will here connect to the battery. So it's a quarter wave resonator, as we can see from the electric field generated. Here it's the cold end here. And the magnetic side, if you're a magnetic loop tester. Okay, now I will explain my point of view. So, using the sensitive microampere meter, I got basically the same results as you, which cannot be another way, because we have here a blocking diode, which will let the current go through only in one direction, and will make that the sensor, the employed sensor, will deplete of charges or saturate of charges, depending on the polarity. So there can not be anything. The white wire is a real earth ground, which is connected here to an outside buried copper plate. So, of course, if I change the polarity, the same thing will happen. So in this polarity, the instrument would go on to the other side, but of course it's not showing anything. It's not possible, because charges can go only one way, and this will deplete the whole wire or sensor or whatsoever. Also, if I attach the copper plate, this will not change anything in this case, because it's a one-way connection. It cannot, the energy cannot circulate forwards and back. So, next test. I will now connect these two diodes together as an Avramenco plug, and of course we get in good distance we get already a very strong reading. This instrument becomes now too sensible for make other tests, so I will further use this one, which has 10 milliamps in each polarity. I have here connected 4 small signal diodes, and now with this connection already we get a little bit of reading, about 1 milliamp. It's not a great thing still. Now we will make the comparison with by using a sensor. I will again connect first the wire alone. Here in the middle as an Avramenco plug, as this connection allows to go the charges forth and back to the sensor. It's the only way that you get a reading, regardless what the reasons for this reading are. The diodes have to be employed this way. Now I will go next to the coil with this, and we get some reading already. And now I will attach the copper plate to see what happens if I increase the capacitance. I get the double of the reading now. It increases to 20 milliamps. And now see what happens if I connect the earth ground to one side of the instrument. This will allow a much bigger circulation of current. You can see already there is a much bigger reading. I'll fix this a little. Sorry. So you can see now at 5 centimeters from the coil, the instrument goes out of scale. I've now removed the copper plate, but the earth ground is still connected to one of the terminals of the instrument. And you can see now, if I go near with the probe, I have considerable less reading. At the same distance, maybe 5 milliamps. Before it was going out of scale, about 12 milliamps with the copper plate. So I think this is quite conclusive that there can be a capacitive coupling in this experiment. Which does not necessarily mean that there is no other thing, that radiation may also be present, which makes a lot of sense to me, this theory. I want to share some more interesting results regarding the measurement of radiation energy with these microampere meters. I have already tested in the previous video this configuration also with only one diode connected, as Sergey used in his experiments. Here the same. This is has a little bit more capacity for higher currents. Here the Kacher-Brovin coil resonator. Can see. Okay. Now I will show you something that caught my attention when I made these measurement tests. When I approach the instrument on one side, I have this reading. Now I will approach the other pole. It stays in 0. It called also my attention that I did not get any significant readings with the bigger instrument, neither on one side nor on the other. It's virtually the same. So the first meter, the microampere meter, went out of range, about 500 microamps. It's okay, the other instrument is very less sensitive, but 500 microamps should be at least visible of it, which not happened. So I decided to do some more tests, which I will show you now. I have now mounted this copper sheet here as a receiver and attached this red wire here with the clip, so I can put it on more precise locations on the meter. You can see here inside is the coil. When I approach it to the coil, nothing happens. I can also go from the side to the coil, from the other side. There is no reflection of the meter when I approach the connector to the coil. Now let's see the diode. We'll first put it on this side. It goes at full scale. Now I will connect it to the other terminal. It remains in 0. One side, the right side, which is the positive side, the direction of the diode is this way. So when I put the clip here, the meter goes to maximum. When I put it to the other side, nothing. Then I try with the other meter with a 10 milliamp range. We'll do the same. Nothing. In the area of the coil, no reflection. The other connector, it remains in 0. So this was what led me to put the Avramenco plug to the bigger meter, and at the moment that I connect the second diode, you will see that the reflection is there. So I have now fixed the diode in the way of the Avramenco plug, and we'll do the test. First at the right side. There is a very small reflection. On the left side, also very small reflection. Now in the center tap, go up to 2.5, almost 3 milliampere. So I made some additional tests with interesting results regarding the scalar wave measurements. Here the Kacher coil. It's as usual configured as quarter wave resonator. It's now, when grounded to the battery, like now, it's resonating at 4.8, 4.9 megahertz. So, okay, I have now made this indicator here, which is a 10 watt, 33 volt power LED. It's a little bit difficult with the daylight, but I will see how to manage. Here you can see it. The Avramenco plug intercepts something. I have now these two small signal diodes. The interesting thing is that I tried with several other diodes, Schottky type, the silicon carbide from Cree, different type of ultra-fast diodes. I even mounted an Avramenco plug with two bipolar transistors, connected in this way, and I got no output, nothing. With none other diode than the small signal types. This is the 1N4146. I also used the 1N60, which is germanium, which also worked. But none of the other diodes gave any result in this, which is a little bit strange. So when I touch it here, I got a very strong light. I also can use the ground wire. This white one is a real earth ground. When I connect it, also it lights up quite strong. Obviously it's the metallic body and the wires of the LED which are receiving now the impact of the waves. But at a considerable distance, there is still some light visible. I'm now at like 40 centimeters from the coil, and they are still lit. So some more thing I want to show you. My reasoning was that if I connect a second Avramenco plug here in parallel, maybe the light would increase. I'll show you. Actually, the contrary is happening. When I make contact with the second Avramenco plug, the luminosity decreases. It's a little bit difficult to see. Now it's one Avramenco plug. Now when 1, 2, 1, 2.